So if you want, I will walk you through how you can build up these different posts so that will be available for you when you are not, means like all the video you can access it. Now today's presentation is demystifying data science, and that concentrate on the logistic regression. Logistic regression, as you know, we go through the agenda today. Introduction to logistic regression, types of logistic regression, sigmoid functions, linear versus logistic regression examples, build a logistic regression model that we are going to do it at end. Now let's start. What is logistic regression? Now, let's start with the linear regression first. Linear regression tries to predict continuous values. However, logistic regression allows us to solve classification problems to predict two or more discrete categories. So here in this, I want you to emphasize it. Linear regression try to predict continuous values, means like housing prices or stock prices. These are continuous values, keep ever changing. However, it is a categorization problem or classification problem. So the logistic regression allows us to solve classification problems to predict two or more discrete categories. Now, the linear regression cannot be used on the data which have classification groups. Now, if you say that the linear regression used to predict a continuous value at a continuous scale, then they will not work better when their data is divided into classification groups. So if there is a binary group, linear regression would not be a good fit. You can transform linear regression to a logistic regression curve. Now, what type of logistic regression that we want to just go through them? Logistic regression assesses the effect of multiple explanatory variable, which can be either numerical or categorical, on the outcome or dependent variable. So what that means is, it assesses the effect of multiple explanatory variables. Means these are the explanatory variables which define the categories. They can be either numerical or categorical. Either it can be 0 or 1, or it can be a color red or blue, or it can be a trace sensitive or not. So we will come to more examples in later slides. There are two types of logistic regression: binary logistic regression, when dependent variable is dichotomous, and multinomial logistic regression, where dependent and outcome has more than two categories. So binary and multinomial logistic regression that we are going to talk and later, and how we solve those problems. But first, I want you to understand a sigmoid function, and which is an important function to understand when you are learning machine learning or artificial intelligence. A sigmoid function is a mathematical function having an S-shaped curve, which is called sigmoid curve, and it's also known as logistic function. Now, the value of sigmoid function is often going either from 0 to 1 or from -1 to 1, depending on convention that has been used. Now, if you see that this is a S-shaped curve, which going from 0 to 1, and the equation is phi z is equal to 1 divided by 1 plus e to the power minus g. Now, if you do that, if we see the linear equation in logistic regression, whenever you have linear model, that means like the rate which is going on this scale, we have, as you know from geometry, we have or state 1. So these are two want to define this category and make a S kind of a curve, we have to form this equation P is 1 to the power plus e to the power minus g, which is we said at b naught plus b1 x. Now we will solve this problem. It's still mathematical, but I want you to be hold tight. Just this is the only part which is little bit mathematical, and I promise that it's nothing is going to be. So let's create a hypothesis function of x. So we have created a hypothesis function x, which we can say y, and this is simplified equation b naught plus b1 x. Now, if you know that the matrix equation, which is we can say the transpose, right? Like if we go through a transpose matrix, so what we can do, we can have like this one. We can have a b naught and b1 here, and onto our this side we can have two variables, which is x naught and x1. So in this scenario, we have x naught is equal to 1, and if we have transpose that, like we can easily get this cross product of this and cross product of this. So this is the purpose we can write this equation is a b transpose x, means we can have a b transpose variable which is multiplied by x. Let me clear that drawing. Now, once you have this form to b transpose x, now what we are going to do, this hypothesis function, which is we are going to make a canonical variable which is divided into 0 between 0 and 1. We have this hypothesis function x, and we transpose into another function, which is we are going to divide a logistic function. This is phi b transpose x. So we put that value, and we know from our equation, if we wanted to build a sigmoid function, that the equation is 1 plus 1 plus e to the power minus g, and if we put that value, we get this function 1 plus e to the power minus b transpose x. Now, if you want to create this phi z, means like if you say this function as g, and the purpose of mathematics is to simplify any equation. So if you see that if we just convert, and because this is constant, this is x value, we can easily form this function to z. Now if we have this function which is becoming this value, then we can see that 1 plus 1 plus y minus b transpose x. And that value we can easily, because we converted this function to z, we have called the equation phi z is equal to 1 plus b power minus b. So now you can see that the way what we have done is we created a logistic regression. Here we transpose into the linear regression equation into a logistic regression using our sigmoid function. Now, if you can see that this is the equation for the logistic function. Now, let's go, if you understood a little bit of mathematics, and probably now you understood why we need to this equation. I think let me just go back. So now you can see the linear model and the logistic model, we get this equation. Now, how we drive it, you might have understood it, but you need not to worry about that, like it's more mathematics already divided and divided unless you have discussed and fine tune it. Now, example of binary classification, let's go through some of the examples that binary classification pertains, like a lot of problems that lie underlying between the binary classification. If a patient would be diagnosed with a disease, that is the problem of the binary classification, whether the patient is sick or not. If a customer would have the ability to pay loan, that is the binary classification. If a mail received in the inbox is spam or not. A catalog company wants to increase the population of making that result in sales is a binary classification. Example of multinomial classification, if we if you want to have these problem, that email, if you receive an email and you want to tag it or you want to put in a folder, it divided by work, friends, family, and hobbies, then it becomes a multi-normal classification. Same way, if you are predicting weather, then weather can be divided into sunny, cloudy, rain, and snow. Medical diagnosis from yes or no question, it can be further classified as model, cold, flu, whatever it is. So now this classification problem, you can see with some example what are the differentiation between binary classification and multi-normal classification. Now, if you have to understand these two concepts of binary classification and multi-class classification, you can think there are two classes. Class 1 is blue triangles, class 2 are red circles. Now, here in the multi-class classification, we have three classes and we added class 3, which is yellow stars. Now, if you want to classify this multi-class classification, we have to classify one versus the rest. So, we start with stars, then we start with triangle, and then we start with circles. And that way, we can identify these three separate categories using this multi-normal class classification. Now, once we classify that, there are the certain equation matrices that are important. And one of that matrix is called confusion matrix. And the purpose of confusion matrix is to define what are the predictions that has been triggered by the algorithm is correct or not. So now, to draw the confusion matrix, we divide this confusion matrix on the x-axis and y-axis. So we have two values, predict actual yes and actual no. Predicted yes and predicted no. If the actual yes and predicted yes are same, that is called true positive. If actual no and when the algorithm predicted no and it was actually no, then it is true negative. Now, there are the two false conditions when actually it was no, but the prediction that was made was false. So, even though it means a patient was not sick, but the algorithm predicted he is sick, and that is called type 1 error. The other type error is false negative and type 2 error. So it means the algorithm has predicted patient not sick, but the hardware was sick. So actually it was yes, but the algorithm predicted it otherwise. So it is type 2 error. So why we define this type 1 error and type 2 errors? The type 1 errors are easy, means like it does not have a significant impact because it's false positive. But false negative is really a significant impact. For example, a patient has cancer, but it is not diagnosed properly, it's a serious consequences. Same way, if a person boarding a flight is established or not, if it is not identified correctly, if it is and it's false negative, then it will be serious consequences. So type 2 errors are, we have to mitigate more of false negative and try to improve our algorithms efficiency and accuracy. So when we talk about accuracy and efficiency, then we have few other measurements that we can consider into that. So now we first go to the accuracy of the algorithm, and that is like we say that true positive plus true negative means whatever algorithm defined correctly divided by totals. True positive, true negative, false positive, false negative. Another is the classification error. So the classification errors will be false positive plus false negative divided by the total number of outcomes. Now there are the two important measurements, which is precision and recall. Precision is true positive divided by true positive plus false positive. So it means, and there is another thing is the recall, by true positive divided by true positive plus false negative. So now, what they say that if the outcome is positive. What is the efficiency? What precisely a algorithm can identify because in case? That is the efficiency, and which is we call precision, and recall is true positive divided by true positive plus false negative. Means that if it is a positive, how often it was correctly identified by the algorithm. So there is a little differentiation between how efficiently it identified the positive cases, and if there was a positive case, how effectively it identified the positive case determined the recall. So we have these two parameter precision and recall, which created the confidence of the algorithm to determine a positive outcome, and that we can again create a harmonic mean, which is F1, 2 multiplied by precision multiplied by recall divided by precision per recall. So it means if we have certain square, the multiplication will take away the errors of these large deviations. Now let me go back into examples that has been laid out here. There is an actual and predicted values. So actual no, there is an actual yes, predicted no, and predicted yes. So true predicted are 100 and false predicted true negative are 50. Here we have false positive and false negative. So we have 10 false positive and 5 false negative. So true negative plus false positive is 60, true negative plus false negative 55, false positive plus true positive, and false negative plus true positive is 105. So now the accuracy that we have said that overall how often is the classifier correct means true positive plus true negative divided by total means 150 divided by 165, which is 0.91. Now this classification rate is false positive and false negative, 10 plus 5. 10 plus 5 equals 165, which is 0.09. But if you know the equation, it is the opposite of accuracy, means 1 minus accuracy will also known as error rate. Now true positive rate, what is actually yes? How often does it predicted yes? So true positive divided by actual yes. So true positive we take it as 100 and actual yes is 105. So means that is 0.95. When it is actually yes, how often does it predicted as yes? This is the sensitivity or recall. Now false positive rate, which is means the opposite of true positive rate, definitely. The when it is actually no, how often does it predicted yes? So false positive divided by actual no, and actual no means is 10 by 60. So false positive 10 and actual no was 60, so means this is 0.17. Now the negative rate, which is opposite of opposite of false positive, which is true negative, when it is actually no, how often does it predict no? Which is kind of opposite of you see the recall. So that is also specificity. So true negative divided by actual no. So true no here is 50 and divided by actual no, which is 50, which is actual no is 60. And so we get 0.83 equivalent to 1 minus false positive rate. Now the precision that we have discussed, how when it is predicted yes, how often is it correct? So true positive means we have true positive is 100, and then out of we are dividing the predicted yes. So the predicted yes is 110. So every time if like our predicted yes is 100, it means our precision is 1. But as we go down the precision means our if we predicted 100 divided by 110, it means our precision is lower. So that determine the rate when it is predicted, how often it is correct, and if you recall what we have seen that when it is actually yes, how often does it predicted yes. So these two parameters and other statistics you can see to improve or get the information about the correctness of your algorithm. Now, as we have discussed some of the concepts related to logistic regression, now it is the time to see how and what that all adds up through a demo which is written in Python using different machine learning library. Now, to do that, I need to share a different algorithm with me, and let's go to the notebook that we are going to open and share. So here we will talk about the logistic regression, and this notebook I have prepared. Now this logistic regression, we start with importing libraries, and this importing libraries we have pandas, which is a data library, and I think in our another data course we go in a great detail how you can work with data. Now, the NumPy and DataPy, these are the two important libraries, and we have a comprehensive presentation on that. Now, the other thing is Matplotlib is a plotting library, and Ciphobot is a plotting library. There are many others that we talk about in visualization presentations. Now, if we have to work on these programs, we have to import them. And to import them, then we imported all the functions which are existing in these libraries. Now, the other thing is we are going with a marketing data file, and marketing data file we are getting is from a public data location. And now let's see what data it has consist. So it is a marketing data of an internet usage of a user so that they can be promoted or for a marketing promotion. Now, this user consists of the users, what daily time spent on their site, what is the age of the users, what is the average area income, what is the daily internet usage of the user, and means we can see the topic line if they get to click onto the topic line. And the city, either this person is a male or female, the country of the residence, timestamps when they clicked on the ad or not. So these are the ad published, and this is the statistics happened that has been collected about the user. So if we see that, we can see the two thing is daily time spent on site, daily internet usage. The area income, age, and male, I think these are the sum of the variables. Now let's go to see how this is going to work. So let's see the data information. We have age, area, income, daily internet usage, ad topics, and we see these are float in and object variables. That is, we can see the data information. If we describe, we can see the first, what about their count of these, what is the mean time spent on the site in minutes, what is the mean age, area income, and daily internet usage and other information. So the male or female ratio, and click on that. We have quarter percentile, have 50% or the 3/4 percentile and max. So we have given all these information if it is useful. Now we are going to create data analysis, which is we setting the SNS library, which is white grade, and we are putting the marketing data as a histogram of 30, so that we can draw and label it as is as. So we see the age, and we want to see how the age factor is distributed among our user group. So you can see that most of the users are dividing in the late 20s to most like late 50s, 40s. Now, if we create a joint plot of area and the age income, you can see that most of the income lies between the people who are 25 to 40 while I'm looking at this. Now, if we go further, we want to create a joint plot between the, we can say the marketing data color blue, and we are using the KD time, the daily time spent on the site. Now, age versus daily time spent on the site, if we create, and we also created the histogram here. So if you wanted to see that histogram, so as age 20 to 40, you see the concentration, the time is maximum time that has been spent, and that was come down drastically. Now, if you see the histogram, like you see the maximum data just come 40 and after it's pretty huge. And the same thing is like the time is histogram is so if you see that from this perspective, this is the age is when large amount of the time. We have understood like a user group how they spending their time. If you want to use daily internet usage, means who's spending more time on the internet, then you can see this this divided figure which can tell it, but it is not going to tell much because it seems to be like that. Now the other thing is the click on ad. This is the, we can create a pair plot. Pair plot is like you are comparing one variable with another. You see that a category blue and red. So if you see the blue category, clicked on ad is if it is blue, it is blue, and one is if they click it. So this is a different histogram that has been created by this pair plot. That will give a more insight if you want, like there is a comparison with each variable to the different variables. So you see the different variables put it onto the x-axis and the y-axis. And there is plot always. So if you go to the daily time spent on daily time spent, you can see like how the graphs are laid out. Now, finally, once we learn more about data and we understood how the data is laid out, and we need to fine-tune it and whatever we want to do, we want to divide and create a train trace script, means we want to train our algorithms that can easily identify train means like we provide both if the user clicked on the ad as well as the features that has been selected for our purpose. Now, if you have seen what feature we are going to take is we want to take a daily time spent on the site, age, area income, daily internet usage, or display a parameter variable is the main or not. And y-axis is click on ad. We did not take the city or other data for now, the click lines, and because they are not vertical variables. So we try to, unless you want to, you can convert them, but in this scenario we have not more data. So we are not doing that. Now we divided the data into 70 or 30 split, means 70% we are going to train and 30% we keep to resolve to cache our data, what model has been trained. Now, if the model we selected is the logistic regression, that is, we use the scikit-learn to get this function from logistic regression model, we fit and transform with our expressed and explained variable, and now we predicted with the model with the cache data. Now, if you are predicting with cache data, this prediction has been stored into the PD variable, which is prediction. And now we can use the confusion matrix and classification approach that has really worked out, and we can say that the y dash means the cache data as well as the prediction, which is the actual and as well predicted. And if you see the two positive, two negative, false positive, false negative, that create a confusion matrix and provide like how the different grade. There was 29 fallouts out of 300, which is kind of okay, maybe less than 10% for a algorithm like logistic regression. And then we also can publish a classification report where we can have a precision and recall icon 0 when it is clicked and 1 separately, or we can have an average of it, which is 0.90 and recall is 0.98. So if the confidence is less than it will be predicted radius is 8, 9, and how often this project radius is from 9 to 0. So like if we combine this after the score is done, the support is 300, where 146 is 0 and 154 is 1. So with this, we have done with this notebook. We can come back and go through some of the go through some of the back to our presentation, see if what we can achieve in this presentation, or if you have any question and answers, we can go through the question and answers. So I'm here back on the presentation. So now again, I'm on to these slides. I think this advertisement data and logistic regression was there, particularly not. A user clicked on the advertisement link, and what we did was evaluate model curves by confusion matrix and classification info. This was the features that has been identified: age, area, income, daily internet usage, and topic lines, city, rate, country, and timestamps, and classification by the model. Click on that zero, one click to indicate clicking on that. So this was our example, and if you have any questions and answers, you have opportunity to do so. Just shoot any questions you have in the question answer window, or you can run the chat. Whatever you prefer, and I'm going to take them one by one. And if you want to speak, you can speak to let me know. So let me just go a few of the questions that has been asked. How did you choose Y? Is it from the data? The question is asked by Kamala Kota. I would say that Y is existing in the data. If you have seen this data, let me just go back. So now the Y variable, we have features. And these are the features: daily time spent on the site, age, area, income, daily internet usage, topic lines, email, country, timestamp, and the user clicked on ad. So the features that we have put onto the x-axis with those features, and the y-axis we put the classification binary, whether the user clicked on the ad 0 or 1. So this was our y variable, and that we assigned to y, and x we assigned these features. But not all of them. We did not, what I will say that we strike out some of the value, and which variable we have strike out. So let's see, we did not use add topic line because this one was headline, and it's hard to validate in a mathematical model. City of a customer, if we have some 3 or 4, we can put a capital variable and take into account. We could have done that same thing. Age, and on the y-axis, which is this is x, and this was our y. So hope I did answer your question. Can I predict the share price using logistic regression? Please send your difficult notebook for that. Yes. So this is Prithvi Mithya. The logistic regression, here we are using the sigmoid function. So it means when we are using a sigmoid function, you can predict whether a share price will be at a certain range or yes or no. But you cannot predict because it's a categorical variable. You can predict based on your input parameters when a price should be 100 or not, or whatever level you want to put it on, whatever you want to predict. But you cannot predict as a linear regression, where I think you have to follow through the linear regression, or I would say that linear regression is not good enough. You have to use certain deep learning algorithm to predict properly the stock complex than what it is, because it is not only based on financial statements of the company, it depends on the macroeconomics like how the political stability and lot of other economical factors, wage rate, labor, a lot of other things are dependent on that. So it can be predicted, but there's a lot more to do. It's not a simple logistic regression. You can work that out. Even if you can work that out, it will not give the result which you want. So here, Kiki Snigdha asked, how can we use logistic regression for multi-class regression? Which package to use for that? Now we have to add on the same process, our multiplication process, and I think we have gone through this this slide. So we have to prepare the multiple scenario. Let me just say it again. I think there is some issue with saying so if I share this one, and I think we have seen this one. If you see that this is the binary classification, there is a class versus points. So we can just pass. Then we go and we can predict primaries versus others, so we know which data is primaries. Then we predict the circles. So in the multi-class classification, we can model with a particular category in each of our predictions. So that is the way we can just go through the multi-class classification. Hope that answers your question. Anonymous attendees have asked, can you share us the notebook? Bhatti also asked, can we share the source code? And Bhatti also said, is it in GitHub? I am to build a notebook I can share, and it is not on GitHub, it is on my laptop, but I can tell how you can access this all the information, which is pretty easy to just do that. I will share more information, but let's see how you can do that. So one of the way you can do that, which I have been doing for a while, you can go to the first one university, and then I have developed this course where I'm just pushing all these lectures or the presentations which I have been taking. All the resources are there. It's not only this one. You can go through all the underlying and different presentations that we have talked about. And I will share those links where you will get notebook as well as the videos which has been done. So hopefully that will help you much better than having this code. Now, if I go back to chat window, which model is suitable for predicting share price? We will discuss those. I don't want to get into the other area of artificial neural network, but we have a lot of algorithm which is related to we will be using to do that. We can talk about those in our the deep learning topics, and definitely that will be a right place to do that. So multi-class is a doing binary classification, and again, is this the most efficient way? If we are using the logistic regression model, that's the only way which we say is that we have a different way to do that, but like if we are using logistic regression, you have to go and stick to this way. Let me go. Okay, so I think I have gone through all of your cases, and I have answered the questions. I don't see any new question for now. Um, if you have still a question, just write me down, or um, I think that's all for today, and I want to thank you for joining the presentation. I want to appreciate you being present and try to explore new things, and hopefully everybody is safe. So stay safe, stay healthy, stay online. Thank you.